Hello, good morning my dear students. Again, welcome to the chemistry class. Yesterday we was discussed about the rate expression, rate constant and rate law. Today we will discuss about the next continuation part of that one, that is order of the reaction. It is hardly a 2 marks questions. Order of the reaction is nothing but we can write the order of the reaction by theoretically by seeing any of the reaction it is possible to write, but it is interrelated to the order of the reaction to the rate expression. We will come to the next one. Consider the general reaction A and B is going to give the product C and D. Here capital A, B, C, D are the reactant and product. Small a, B, C, D are the stoichiometric variable, means coefficients variable. So here experimentally determined rate law will be for a general reaction is, in the yesterday we discussed this one, rate is equal to K into concentration of the reactant and X by the exponential power. These powers are calculated experimentally, not theoretically. So based on this, here can you see here X is the exponent, X is the order of the reaction with respect to the component A. Means order of the reactions can be expressed with respect to each of the reactant. With respect to reactant A, the order of the reaction is X, where Y is the order of the reaction with respect to the component B. Means together the overall order of the reaction is the exponential value of reactant, concentration of the reactant. Therefore, X and Y are the powers of concentration of these two. This X plus Y together we are writing that as N. Here N is the order of reaction. So we can able to write the order of the any given reaction only if they have given the rate law. If they given the rate law expression, it is possible to write order of the reaction. If they have given only general reaction, it is not possible. No doubt, order of the reaction is theoretically written, but rate expression can be written experimentally. We are writing the order of the reactions based on the rate law expression. Therefore, it is theoretically, but to write this expression, we need the experimental values. So, based on this one, order of the reaction is the sum of powers of the concentration of terms of each reactant in experimentally determined rate expression. This is the rate expression. Here we are adding the powers of X and Y, where these are the exponential power of concentration of reactant. The sum of X plus Y, this is N itself, is called as order of the reactions. Means this order of the reaction, it may be a 1, 2, 3 or it may be a 0. Maximum it will be the 4. And commonly order of the reaction more than 3 is unlikely. Means order of the reaction, it may be a whole number or it may be anything, but more than 3 it is not fair, it is not happening. If it is happening, means somewhere it is go through the mechanisms. Therefore, order of the reaction is maximum 4 or rarely it is 3. And order of the reaction can be a fraction, because if the powers are thing that if X is 1 and Y is 1 by 2, together sum 1 plus 1 by 2, it is 3 by 2. Means order of the reaction may be a fraction. Next one is order of the reaction can be a negative. It is not supposed to be a positive. It may be a negative, it may be a fraction, or not more than 3. You should remember that one. And moreover, we are determining this order of the reaction by this expression. Hence, it is depends on the mechanism and it is related to the concentration of the reactant. If some of the reactions seems to be a more order of the reactions are more, but we know that it is not possible more than 3. Therefore, if it is more than 3, we will check out the mechanism. Based on the mechanism, we are writing the orders. We will come to know when we move to the examples. For example, here consider this reaction. The rate expression, experimental value for this reaction can be given as rate is equal to K into NO. These are the two reactant and having the exponential value 2, and this 2 is having the power 1. In the last class, we have discussed how these 2 and 1 are calculated experimentally. And based on this rate expression, it is possible to write the order of the reaction. Can you see here? Order of the reaction is nothing but it is the sum of the exponential power of concentration of reactant in the rate expression. Here power is 2 and here is the power is 1. Therefore, order of the reaction of this rate of the reaction is 3 because the power is 2 plus 1. If they have not given this expression, it is not possible to write the order of the reaction because order of the reaction is theoretically written, but if we don't know the rate expression, it is not possible. Means based on the general reaction, it is not possible to write. Therefore, it is theoretical, but we need experimental value to write the order of the reaction. Next one is, it is important, SI unit of rate constant. Rate constant is nothing but K. The K is called as rate constant. Here, consider the general reaction, same once again, A plus A. Consider the general reaction once again, AB, it gives C and D. Here, the rate expression is nothing but K is equal to concentration of the product of A and B and exponential X and Y, where X plus Y is equal to N, where N is nothing but order of the reaction. You just concentration this one, how I am writing this. We need the rate constant, means K assigned. Therefore, I will rearrange this one. K I will keep here only. The concentration of this A and B I am setting here. This into becomes divided, rate divided by concentration of A and B. Therefore, K is equal to rate divided by this one. Whereas we know that rate of the reaction can be expressed in the terms of minus delta R divided by delta T. Means it is the rate expression. Why I have given this one means instead of this rate I am writing this rate as dr by dt. Means rate of the reaction in terms of decrease in the concentration of reactant. But I am not mentioning minus. Here R is nothing but concentration of the reactant divided by time. Therefore, I will keep K as it is. Instead of rate I am writing concentration divided by time, because rate is expressed in the terms of concentration divided by time, into the reciprocal of product of concentration of reactant. Here AB are the reactant, square bracket indicates the concentration. Concentration of the power is N. Why I have written N means, can you see X plus Y? The sum of X plus Y is nothing but N. N is the order of reaction. Therefore, instead of writing separately the reactant A and B, I have written as A and B are the concentration of reactant. Generally, it is concentration of reactant. Here, the power N indicates the order of the reactions. So, I hope if you remember this one means it will be the easier. Still, it is important is in the next slide. Can you see here the unit of the rate expression is expressed in terms of K is equal to concentration divided by time. It is the rate expression into reciprocal of concentration of the reactant rise into the order of reaction. So based on this one, we are writing the rate of a constant. Here, if concentration of A and B, if they are having similar, then only it is possible to write the concentration. Why I am writing this one only because of together I am writing concentration of A and B are together it is concentration of reactant. The power N indicates the order of the reactions. The next slide is the same thing. Here see, look here. Unit of rate constant for zero order reaction. Zero order reaction is nothing but if the N is 0, N is nothing but order of the reaction. If N is 0, we are saying that order of the reaction is 0. If N is 1, the order of the reaction is 1. Similarly, unit of means SI unit of rate constant of zero order reaction. We are writing that the concentration SI unit is mole per liter and time is having the SI unit second into 1 divided by concentration of reactant. Again, the concentration is same for the both reactant. Therefore, mole per liter. Can you see here the concentration is raised by N, power is N. Here N I have written as 0. Why? Because we are discussing the SI unit for zero order reaction. If N is equal to 0, then it is called as zero order reaction. If anything raised to 0, if to any of the value the rise to the power 0 is, it will becomes unity, it will becomes 1. Therefore, it will be cancelled, it will become 1. Therefore, remaining is mole per liter. The second moves to the upward. Therefore, second converted as per second. Therefore, SI unit mole per liter per second is the SI unit of rate constant for zero order reaction. Based on this SI unit, you can be able to express the order of reaction. If the order of reaction is 0, then it should have the SI unit mole per liter per second. Similarly, SI unit of rate constant for first order reaction means we are writing n is equal to 1 here. Can you see here? Mole per liter is the concentration SI unit, and second for the time, and concentration of n I have written as 1 because it is first order reaction. In the first order reaction, when it is 1, can you see here in the numerator and denominator it is having the same value, mole per liter, and this is one is also mole per liter. Therefore, these two will cancel each other and remaining is only second. Second is in the below. Therefore, if it moves to the up, it will becomes per second. If the rate constant is having the SI unit per second, it indicates that the order of the reaction is 1. Order of the reaction is 1. It's based on SI unit per second. Next one is SI unit of rate constant of second order reaction is same thing again. Here we are writing the n is equal to 2 because of second order reactions. Can you see here? Here it is 1 and here it is 2. If it comes above means it will becomes minus 2, or if it cancels one of the mole per liter here and we will cancel one of the mole per liter here and remaining still one will be remaining. Therefore, one of mole per liter will remains. These two will be cancelled by cancelling this above mole per liter, and remaining is mole per liter. This mole is positive. When it moves to the upward, it becomes plus 1 becomes minus 1, and minus of means per liter, minus 1 becomes plus 1 per mole liter, and again it is per second. You just remember this one is confusing, don't get confused. The second order reactions SI unit of rate constant is per mole liter per second. You are not supposed to forget this SI units because sometimes some of the reactions are calculated, means if the SI unit they will give the rate constant K value, and if they are having the SI unit mole per liter per second without any calculation, you can write it is 0 order because the SI unit of this one. If they have given the SI unit per second, then you have to write this as first order. Based on the SI unit, it is possible to write order of the reactions. So generally, SI units of rate constant of nth order can be written as here mole raised to 1 minus n liter to the power n minus 1 and per second. Why I have written here 1 minus n? The mole is having raised to the power 1 minus n. For the nth order is nothing but for the 0 order of the reaction, you just put n is equal to 0, and here you just put n is equal to 0. You are going to get the first order reaction. Similarly, you need fifth order of the reactions. Rate constant for fifth order, you have to write n is equal to 5, and here also n is equal to 5. You are going to get, if you want to calculate any nth order of the reactions SI unit can be calculated by this expression. So last one, you are having the homework, and once again I am remembering, if I have written, you are having my class around 11 o'clock, means if I will launch this video at 11 o'clock, I hope it will be not having more than 20 minutes. 20 minutes means still you are having half an hour. So at that time you can write it and you can post it to me. Don't take it at a granted. You are having, you can see it anywhere at the night or tomorrow you can see. Don't do like that. So if it is given today means today itself, it is better to post within college time so that I can see it. If you are having any doubts, if you are written any wrong means, I can make you or guide you to the correction. Therefore, don't be late, don't be hurried to write it at the time when I tell you to be bring to the college and show you. Therefore, do the today's work today only, and how much it is possible, try to send these answers and also written notes to my WhatsApp number. Okay, I hope this must be clear for you all. If you are having any doubts, please ask in my WhatsApp. Okay, we will meet in the next class. Until